So now let's start section 13.5, which is about chain rules for functions of several variables. So we're going to start with the chain rule in the case of one independent variable. So we're going to suppose that we have a function of two variables. So let's go with let w be equal to f of xy, where f is a differentiable function of x and y if x is equal to g of t and y equals h of t, where g and h are differentiable functions of t, then, so w is a function of x and y, but x and y are both functions of t, so w is really a function of t. And w is a differentiable function of t, and the derivative of w with respect to t, it's the partial derivative of w with respect to x times the derivative of x with respect to t plus the partial derivative of w with respect to y times the derivative of y with respect to t. So the only places where you have partial derivatives are when you're looking at the derivatives of y with respect to x and y. Those are partial derivatives, and the rest of them are just regular derivatives, derivatives of functions of a single variable. So let's look at an example here where we find the derivative. So let's look at the following. Let's suppose w is x squared y minus y squared, where x is equal to sine t and y equals e to the t. And I want you to find the derivative of w with respect to t when t equals 0. So we're going to start by using the chain rule that we just had. So by the chain rule, we know that the derivative of w with respect to t, it's the partial derivative of w with respect to x, dx dt, plus the partial derivative of w with respect to y, dy dt. So let's look for what's our partial derivative of w with respect to x. That will be 2x y. That's the derivative. And then you're going to multiply by the derivative of x with respect to t. So what's the derivative of x with respect to t? It'll be cosine t. Now we need the partial derivative of w with respect to y. The derivative would be x squared minus 2y. And then I need the derivative of your y equation with respect to t. The derivative of e to the t is e to the t. Now, you should only have t's in your equation, so we need to get rid of these x's and y's we have here. X and y and x and y. And to get rid of those, you're going to go back up to your substitution equations here and plug in x is sine of t and y is e to the t. So dw dt will be 2. X is sine t, y is e to the t, cosine t, and then x squared, so it'll be sine squared t minus 2 e to the t times e to the t. And if you want to, you could go ahead and simplify this. It's not required, but let's see, I have 2 e to the t sine t cosine t plus sine squared t. We have an e to the t there that we distribute. And now all I got to do is plug in my value of t. I was told that t equals 0, so you're going to plug that in to get your derivative. So 2 e to the 0 sine 0 cosine 0 plus e to the 0 sine squared of 0 minus 2e to the 0. Sine of 0 is just 0, so this term 0, this term 0. So you're going to get a negative 2 for the derivative. dw dt will be negative 2. And there's my answer. Now I do want to mention that you didn't have to use the chain rule on this problem, so unless you're specifically told you had to, but without using the chain rule, you could have gone to your equation for w and plugged in your equations for x and y. So x, and then x was sine t, and then y was e to the t, so w would be sine squared t e to the t minus e to the t squared e to the t sine squared t minus e to the 2t. And then you could have found here w is just a function of a single variable, so dw dt, and then you would have had to use the product rule here. So let's see, e to the t, the derivative of sine squared would be 2 sine cosine plus the derivative of e to the t, which is e to the t sine squared t, and the derivative of e to the 2t would be 2e to the 2t by the chain rule. So if you compare this with our previous answer, you would see that we had the same formula for dw dt. If you look back at dw dt, we have the exact same formula there. So you could have either used the chain rule or you could have done substitution.